All right, so today we're going to be talking about more polynomial division and remainder theorems. So we're not going to cover anything new today. We're just going to be reviewing the concepts that we did last class. We're just going to be taking them a step further than what we were doing last class. So it's going to up the difficulty a little bit. Let's get going. So again, we're reviewing the concepts from last class. In case you've forgotten what those concepts are, they include synthetic division to divide a polynomial by a binomial. I'm not going to look at long division today. I don't think that's a big one to be worrying about. So I'm just going to focus on synthetic. We'll look at remainder theorem again to find the remainder without actually doing any division. And then we'll look at some more advanced problems. Now I know it says be prepared to collaborate. That would be if we were having an in-person lesson. Let's get going. So just remember that when we divide a polynomial by a binomial, we end up getting a quotient, and then most of the time we also end up getting a remainder. So the quotient is typically a polynomial in and of itself. The remainder, however, is pretty much always just a number. Matter of fact, I can say it is always just a number, right? So when we write out a polynomial division statement, when you have your polynomial divided by whatever you were dividing by, this will equal your quotient plus your remainder over whatever you were dividing by in the first place. There's another way you can write this where you say it's like the quotient times what you were dividing by. I never use this one. Let's be honest here. I think that's kind of silly. This one is way better in my opinion, but hey, you know what? If you want to use that one, go for it. It's totally valid one way or another. All right, so here's our first example of the day. I would really appreciate it actually if you pause the video on each one of these and give them a try, but I'll read it first. Use synthetic division to find q of x and r, so your quotient and your remainder, if that is divided by that. I would appreciate it if you pause the video here and give this one a try, and I'll go over it in a second. All right, I'm going to go over this one now. First things first, before you start your synthetic division, just make sure you have all of your x's here. Well, we have x cubed, x squared, x, and then a number. It looks like we're totally fine here. So when we do synthetic division, we want to make sure that we list out our coefficients. So the very first coefficient I'm going to write out is the one in front of the x cubed, which is just a 1, right? And then we have -2 here, so -2. Then we have -24, and then we have +62. And then I draw a box around this, giving myself some space underneath. And then on the left side of the synthetic division thing, we write what we see in our binomial. In this case, we have x minus 5 is what we're dividing by. Again, you write what you see. We see a -5 in there, like a -5. So I'm going to put -5 up here, and then I always put a minus sign right here just to remind me of what I'm doing. The first term gets dropped down, so the 1 drops down to here, and then you start your cross stitch kind of pattern, right? So we go 1 times -5. Well, 1 times -5 is -5. -2 minus -5, I'm pretty sure that's +3. And then we have -5 times +3, well, that's -15. -24 minus -15, that's going to be -9. And then -5 times -9, well, that's 45, +45, because it's a negative times a negative. And then 62 minus 45, I think that is 17. Now, how we interpret this result here is we read it from right to left. The furthest right number is going to be your remainder. So this one right here, that's our remainder. Then we just go up in order of degrees. So we say this is our number. This would be our x, and this would be our x squared. So in order to find our q of x and our r, well, we can say q of x, our quotient here, would be 1x squared plus 3x minus 9. That's just using these coefficients we found here. And then our remainder, of course, is 17. If you wanted to be super fancy, and if you wanted to write this as like a division statement, you could have written x cubed minus 2x squared minus 24x plus 62, all divided by x minus 5, equals your quotient, which is x squared plus 3x minus 9, plus your remainder of 17 over what you were dividing by in the first place. Both of these sides of the equation, both of them are completely equal to each other. And you can multiply both sides by x minus 5 to hit this and this and this, and you'll see that it actually is all the same. It is a lot of work, though. You can kind of just take my word for it. It is, whatever you want to do, whatever you want to do. That's all I'm saying here. Anyway, moving on. Next one, use synthetic division to find the quotient and remainder of this. Now, this one's a little weird. It's kind of all scattered. And it says also express your answer as a division statement. So this time around, we have to do that. If you wish, you can pause the video here and try it on your own. But aside from that, I'm going to go over this now. So the biggest problem with this one is it's all jumbled up. But here's the good news. If we look at the numerator and we look at the denominator, you can reorganize that. There's nothing wrong with that. Multiplication or with addition and subtraction, the order, as long as you're just careful with your coefficients and stuff, you're just fine, right? So I'll just reorder this so it's in proper order due to degree and all that. So I'll write this as 4x cubed plus 9x squared plus 8 over x plus 2. These mean the exact same thing. So this one just on the right that I've reorganized, it's just in a better order. Now we want to use synthetic division on this one. Notice we're missing an x in here, right? It goes from x squared and then right down to a number. Technically, there's a 0x hidden in between this here. We got to put that into our synthetic division, otherwise we're going to have a bad time. So my synthetic division here is going to be 4, and then 9, and then 0, because there's 0 x's, so 0, and then 8, and put this in a box. On the left side of the box, you put what you see and what you're dividing by. So we have x plus 2. What I see there is a positive 2. And then we always subtract and bring down our first term. Once we've set this all up, like that's honestly the bulk of it, now we just start our cross-stitching kind of pattern. So I'm going to go 2 times 4. Well, that's 8. 9 minus 8, that's just 1. 2 times 1 is 2. 0 minus 2, well, that's negative 2. And then 2 times negative 2 is negative 4. 8 minus negative 4, remember that's a double negative there, 8 minus negative 4, that's going to bring us up to positive 12. So this positive 12 is our remainder, this is our number, this is our x, and this is our x squared. I always just write that in there. I always think that's just a nice idea. It keeps your stuff all straight and ready to go. Anyway, let's write this as a division statement. Oh, I guess it wanted us to say find the quotient or remainder. Well, whatever, here it is. Q of x, our quotient is 4x squared plus 1x minus 2, and our remainder is 12. There we go. We satisfied this quotient and remainder. That's all good. Now for our division statement, we'll say it's our polynomial that we started with. That's 4x cubed plus 9x squared plus 8 over x plus 2. This division is going to equal, that's not a very good equal sign, 1 second. This is going to equal our quotient, which was 4x squared plus x minus 2 plus our remainder, which was 12, over what we were dividing by in the first place, x plus 2. Boom, that's it, right? That's our division statement. Very, very important for you to understand how synthetic division works. In a little while here, a couple lessons from now, we're going to actually have to pretty much know how to do this like the back of our hand, right? So this is a really good foundational skill to be building for the rest of this chapter. Now, we got to talk a bit about a weakness of synthetic division. Synthetic division is not perfect. There are some situations where it's not ideal. The good news is these situations don't really come around very often. So suppose we're asked to find Q of M, it's the same idea as Q of X, we're just using M as a variable instead. Q of M and R for the following polynomial division. We got the whole thing going on here. Now, is this possible using synthetic division? Well, the answer to this is more complex than that. It's kind of just sort of. Now, here's what I mean by sort of. When we use synthetic division, the whole setting up with a box and all that, we assume we only have one x, or in this case, one m, in what we're dividing by, like that binomial there. This time around, we have 2m. So at face value, as it is right now, no, we can't divide this using synthetic division. You would have to use polynomial long division on this one. However, you can get kind of crafty with this. If you factor out a 2 out of the bottom, let me just kind of rewrite this. If you factor a 2 out of the bottom, that's going to give us 2 times m plus 0.5. So I just divided each of these by 2. You can bring that back through and you'd have 2m plus 1. And if I factored a 2 out of the top, 2 times, if I divide all of these by 2, we have negative 3m cubed plus 5m plus 13 divided by 2 is 6.5m squared minus 6 divided by 2 is 3. If we divide everything by 2 on this one and factor it out, now we can knock those 2's out of the top and the bottom. And this stuff that we're left with, this could be done using synthetic division. So we'd be setting it up with a 0.5 up in the corner and all of these coefficients here, although you have to rewrite them so they're in the proper order. You could do synthetic division at that point. My idea on that is, though, I don't know if you'd really want to, right? First of all, having this number 0.5 being what you're cross-stitching through, it would probably suck, right? It is very much possible. It is something you definitely could do. So yeah, sort of. Synthetic division is possible when you have more than one x in what you're dividing by, or more than one m in this case. But I just wouldn't necessarily do this. So this is where I eat my words a little bit and say, you know what, sometimes probably better to use long division. but I'll be real with you. You don't really ever see these. As a matter of fact, I can say with pretty full confidence, unless they're very, very cruel on a diploma exam some year, you won't ever see one of these, right? Anyway, moving on. Here's something a little bit more typical. These are really strange. They're kind of puzzle questions. So if x plus 3 is the divisor in the following synthetic division, calculate the values of m, n, and p. So we got some missing things in there. We want to figure out what is going on. Well, the only thing we can do on something like that is we know x plus 3 is the divisor. So that means I'm going to have to put a positive 3 out here. And we're just going to have to start this as we usually would. Remember, I always usually put a minus sign here, and then I drop down my first term. So a 2. Let's just see where this is going to take us. Hopefully, it'll take us somewhere. 3 times 2, well, that's going to be 6. 2 minus 6, well, that would be negative 4. And then 3 times negative 4 is negative 12. And this is where we hit a bit of a stump, right? We got negative m minus negative 12 is going to equal 2m. Well, just kind of write out what I just said there. Negative m minus negative 12 equals 2m. Let me write this over here. So negative m minus negative 12 equals 2m. Why don't we just gather all our m's on one side? What if I add m on both sides here, and this double negative is going to cross itself out? So if I add m on both sides and this minus a negative becomes just a positive, we're going to have 12 equals, adding m on both sides gives me 3m. And now I can solve for m, right? I can just divide by 3 on both sides. So this is going to give me m equals 12 divided by 3 is 4. Boom, look at that. I found the value of m. We got 1 down, 2 to go. So we know m is 4. Since m is 4, what do you think 2m is? Well, 2m must be 2 times 4, which is 8. And then how do we jump from 8 to n? Well, this should be the exact same number, right? We always just, oh, sorry, it shouldn't be the exact same number. My mistake. It should be 3 times 8. I don't know what I was thinking there. 3 times 8 should give us n. So 3 times 8, well, that's going to be 24. And 24 will take the place of n right here, 24. So we have m and we have n. Both of those are done. Now we just have to find p. I think this one's probably the easiest of the bunch we've had so far. 16 minus 24 should give me p. So 16 minus 24 equals p. Well, 16 minus 24, that's negative 8. So p equals negative 8. Perfect. We got all 3 of those terms. So these kind of puzzle questions, they do actually show up every now and then. They're kind of weird. I think I've seen them on diploma exams, actually. So just make sure you're just at least giving it a start, right? Start with what you know. We know that when we are doing synthetic division, we have to put a 3 up here and then do the whole cross stitch pattern and all that, right? So as long as you set it up and just start it, it should give you some clues as to where you're going. But yeah, anyway, moving on. All right, so here's a remainder theorem one. Remainder theorem was pretty straightforward yesterday. Remainder theorem is just basically where you plug in what would make your binomial equal to 0 into your polynomial that you're dividing. That'll tell you what your remainder is. So in this binomial, if we were dividing p of x by x minus 4, to make this binomial equal to 0, x would have to equal 4. So if we plug in x equals 4 into this polynomial, that'll tell us our remainder. That's what remainder theorem does. So plugging in x is 4 into this gives me 4 to the power of 4 minus 4 times 4 to the power of 3 plus 5 times 4 minus 1. Now I'm going to be very crafty here. 4 to the power of 4 minus 4 times 4 to the power of 3. Those are going to actually cancel each other out. And if you don't believe me, you can always type in your calculator. Long story short, I know this is just going to be 5 times 4 minus 1. This is going to give me 19. So 19 would be my remainder if I was dividing by x minus 4. If you didn't know about remainder theorem, you'd have to use synthetic division on this. Keep in mind, we're missing an x squared in the middle, so you'd have to put a 0 in for that. It'd be a lot more time consuming. Remainder theorem, where you just plug in whatever makes your binomial equal to 0, saves you a huge amount of time. Now, what about this next one, x plus 3? Well, this time around, x would equal negative 3 to make this binomial equal to 0. So we're going to plug x's negative 3 into this. Be very careful. When you're taking powers of a negative, you have to be careful with our brackets, right? So this is going to be negative 3 in brackets to the power of 4 on the outside of it, minus 4 times negative 3 to the power of 3, plus 5 times negative 3 minus 1. This is one I'm definitely going to want to throw into my calculator, so bear with me here. Negative 3 to the power of 4 minus 4 times negative 3 to the power of 3. Where am I? Okay, plus 5 times negative 3 minus 1. I got 173. I sure hope that's right. Double checking my work there. Yeah, it looks like I punched in everything correctly. Yeah, so 173. That's a huge remainder, but 173 would be our remainder there. And again, if you're ever not sure, you could always use synthetic division and it'll come out as your remainder there. But nobody's got time for that. Let's be real here. Moving on. All right, so this is a more tricky problem. We did one kind of like this yesterday, I think. When the polynomial p of x equals that, notice there's a k in here though, so we don't know what the value is there, is divided by x plus 3, the remainder is 25. Find the value of k. All right, so since we're given a remainder, this is probably going to be a remainder theorem question. Let's plug in x is equal to whatever makes this equal to 0. Well, that would be x is negative 3. Throw negative 3 into this. I know we don't know what k is. Give it a shot either way, though. Let's try this. So negative 3 cubed plus 3 times negative 3 squared plus k times negative 3 plus 10. So we plugged negative 3 into all this. That's going to give us our remainder of 25. Let's see if we can clean up this side over here. Negative 3 to the power of 3, well, that's going to be negative 27. Plus 3 times negative 3 squared. Well, negative 3 squared is 9, positive 9. 9 times 3 is 27. Look at that. Those are going to cancel. That's quite convenient. Plus k times negative 3. Well, that's just going to be minus 3k. And then plus 10 equals 25. These are gone because negative 27 plus 27 cancels itself out. Let's minus 10 on both sides. We got negative 3k equals 15. Bingo, bango, bongo, divide by negative 3 on both sides. We got k equals 15 divided by negative 3 is negative 5. So this is actually minus 5x in there. That's what that's actually meaning there. So cool, we found what k is equal to. Second part of the question, find the remainder when p of x, that's this function here, is divided by x minus 1. Well, it's a good thing we found what k is, because now we can just use remainder theorem on this time plugging in x equals positive 1. That's what would make this whole chunk equal to 0. Throw x's 1 into this. I'll just show all the work here. 1 cubed plus 3 times 1 squared. And remember, k was negative 5, so we'll say it's minus 5 times 1 plus 10. Throw that into your calculator if you need. Honestly, I think I can do without. This is going to be 1 plus 3, so 4. 4 minus 5 is negative 1. Negative 1 plus 10, well, that would be 9. So just a little bit of mental math there, and I was able to figure that one out. So the remainder can just be found using your remainder theorem. Quite nice. Now, something not quite nice. This is a very tricky problem. This is about as advanced as remainder theorem kind of questions get. Here we go. So when f of x equals that whole chunk there, and notice we have an a and a b missing. We don't know what those are. When this whole chunk is divided by x minus 2, the remainder is negative 27. However, when f of x is divided by x plus 3, the remainder is positive 103. Find the values of a and b. If you're feeling really bold right now, and you're in for a challenge, and I kind of suggest this, maybe you could pause the video here and see if you could give this one a try. All right, so whether you got it or not, I'm going to go over this. Hopefully we can see if we can get this one. So first of all, I'm going to test this x minus 2. Of course, if we're going to use remainder theorem on that, I have to plug in x equals positive 2. Throwing in positive 2 into this gives me negative 3 times 2 cubed plus a times 2 squared plus b times 2 plus 1 equals the remainder, which was negative 27. Let's clean this up a bit. 3 times 2 to the power of 3. Well, 2 to the power of 3 is 8. 8 times negative 3 is negative 24. Plus a times 2 squared is going to be 4a. Plus b times 2, well, that's 2b. And then plus 1 equals negative 27. Why don't we gather all of our numbers to the other side? So I'll minus 1 on both sides. That'll give me negative 28 over here. But then I'll add 24. So this gives me 4a plus 2b equals negative 4. So there's nothing I can do with this at this point. This is something with 2 different variables in it. You can't solve it if there's 2 different variables. So now I'm going to jump over to the other one where we have a division by x plus 3. What I'm going to test in remainder theorem is x equals negative 3 this time around. So if I plug negative 3 into here, let's see what we get. So we've got negative 3 times negative 3 to the power of 3 plus a times negative 3 squared plus b times negative 3 plus 1 will equal our remainder, which this time is 103. Let's clean this up. Negative 3 to the power of 3, that's negative 27, but negative 27 times negative 3 is positive 81. Plus a times negative 3 squared, well, negative 3 squared is 9, so this is plus 9a. And then plus b times negative 3, well, that's going to be minus 3b. And then plus 1 equals 103. Just like in the last one, let's move all of our numbers over to the other side. So I'll minus 1 on both sides. That gives me 102. 102 minus 81. Oh, I feel like that's 21. You know what? I'm going to double check just to be sure. 102 minus 81. Yeah, of course, it's 21. Awesome. Just wanted to be sure. 9a, not plus, 9a minus 3b equals 21. So here's something quite tricky. This is a throwback to both Math 10C and Math 20-1, but it's doing it in quite a mean way. By a throwback, what I really mean is we have two different equations that have two variables in them each, and they're both equal to different things. This is what we call a system of equations. You can solve a system of equations in one of two ways. You can either use something called substitution. This is where you get one variable by itself and you substitute it in the other equation, or you can do something called elimination. Elimination is where you line up your variables and then you can see if you can multiply one of them by something and then knock it out. It's a lot of work. Long story short, I'm going to see if I can use substitution here. So in either one of these equations, I want to see if I can get one of my variables all by itself, at least in a way that's going to be more comfortable for me to work with. Well, the thing that I think is a little bit more comfortable here is I want to see if I can get maybe b by itself here. And the reason being is, just using my imagination, I can imagine that I'll move 4a over and then divide by 2, and I won't be dealing with any decimals because decimals just make things more complicated. So let's try this. If I'm going to minus 4a on both sides here, I'm going to have 2b equals negative 4 minus 4a. And then if I want b totally by itself, I just have to divide everything here by 2. So b equals negative 2 minus 2a. So I just divided everything by 2. B is now by itself. What I do with this, because I know b is negative 2 minus 2a, I can take this and I can plug it into the other equation. Watch what happens when I do that. I'm actually going to just change color real quick. If I plug this into the other equation, so I'm swapping b out with this chunk right here, I'm going to end up getting 9a minus 3, and then instead of b, I'm going to write negative 2 minus 2a, and that's going to equal 21. Now we got to be really careful here because this 3 has to double dip through. So 9a, and then this is minus 3 times minus 2, which is going to be plus 6. And then it's going to be minus 3 times minus 2a, which is going to be plus 6a. And that equals 21. Now we can collect our like terms. I'm going to move 6 over to the other side. And I'm going to add these a's together. 9a plus 6a is 15a equals 21 minus 6. That equals 15. Now we should hopefully know how to solve this. 15 times a equals 15. We'll just divide by 15 on both sides. And we have a is equal to 1. We've now figured out one of our values. Here's the question though. How do we find b? Well, here's the great news. Notice back in our formula for b where we got b all by itself over here, b is just negative 2 minus 2a. We know what a is equal to now. Let's just solve for b. So b equals negative 2 minus 2 times a. A is 1. So this is going to be b equals negative 2 minus 2. And that, of course, is going to give us b equals negative 2 minus 2 is negative 4. So look at that. Very tricky example. If you got this on your own, great. If you didn't, don't kick yourself. But just make sure you understand the strategy for going about this. It's all about setting it up as a system of equations where we have one equation and another equation that have the same variables but a different thing it's equal to. And then either using substitution or elimination to solve it. I think substitution is way easier. Substitution, again, is where we just set one of the variables all by itself and then substituted it into the other one. But whatever floats your boat, honestly, you can solve this in either way. And with that, we are all done for today. So for practice, page 124, questions 2 to 10 and 14. There's also the assignment for this chapter. You can get a good start at that right now. I think you can do at least the first couple pages. We're going to be really expanding on this idea of remainder theorem next class. So you'll need to think kind of in advance. What does it mean if we use remainder theorem and find that a binomial gives a remainder of 0? What does it really mean for us to divide a big polynomial by a small binomial and get a remainder of 0? What does that really mean? And also, what makes the point x equals a, so the thing you would plug into remainder theorem, what makes that so special in this situation? We'll worry about that next time. For now, just worry about the questions we've got. If you have any questions, as always, please let me know.